Everyone, how's it going? Dan here, co-founder of PromptUp, and today we're going to talk about prompt engineering with reasoning models like O1 Preview and O1 Mini. And so it's a question that we've been getting a lot recently in terms of how the prompts should be different. OpenAI gives a little bit of guidance on it, but there hasn't been much more than that. It's a couple of bullet points, and so we did some research here looking at a lot of recent research papers that have come out about this topic exactly. So we'll talk about the different prompt engineering kind of methods and techniques that work for non-reasoning versus reasoning models, when specifically to choose between the two, some guidance there, and then performance on specific tasks, and then also just overall best practices. So it'll be a little bit longer today. We'll try to move pretty quickly forward. So first question, when to use a reasoning model versus a non-reasoning model. And so, like I said, we'll look at which model performs on better tasks, like specific tasks outside of benchmarks, which prompt engineering methods work best for each, and an objective way to pick a model. So this first paper, do advanced LMs eliminate the need for prompt engineering and software engineering, focuses of course on software related tasks, so code generation, code summarization, code translation using GPT-4o and O1 Mini. And there are a bunch of results that we touch on in our full-length article, which will be linked below, but here's the one from the code generation, and a couple of things obviously stand out. So these are all the different prompt engineering methods on the left, and you see for both models you're not getting a ton of gain. In some of these other ones for GPT-4o you're seeing that's pretty important gain, going from 90 to 96, but this is certainly less than previous models, and then especially for O1 Mini you'll see that delta is even smaller. And just as a technical note, to do chain of thought, they had GPT-4o create the chain of thought and then included that in the prompt for O1 Mini, because you can't really prompt O1 Mini to do the chain of thought in the output itself, since it does it automatically. Code summarization, in this case you could see for O1 Mini using FewShot actually resulted in worse performance, same with a bunch of the other methods. So this kind of goes to that trend where that using prompt engineering methods that worked for previous models, using those on the reasoning models can actually result in worse performance. And the trend kind of continues. We won't spend too much time there. So overall, GPT-4o still benefited from prompt engineering techniques, and I still think there's some value there, specifically in relation to these code type tasks. And is able to even get to O1 Mini like performance. And so that's something to keep in mind with cost and latencies. And then for O1 Mini, the built-in reason capabilities made like a more straightforward, simple zero-shot prompt as effective, if not more, than using some of the more complex prompt engineering methods. Second one is an update to an original paper. So Medprompt was published by Microsoft sometime last year. It was a paper that released a prompt engineering framework. So that's what Medprompt is. It's a prompt engineering framework that was able to beat fine-tuned models on medical data sets from just like a model off the shelf. We covered this originally because it was a very interesting paper, and now we're doing the update on it. So basically they added these 5 different prompt engineering methods, techniques. So going from zero shot to adding FewShot to chain of thought, FewShot, so on and so forth. So a couple of different things being layered on top. Here you can see the incremental difference from each of them. And so they did this with GPT-4 in June, and then they've come back and updated it to use O1 Preview and do the tests, kind of same tests here. And so what you can see again is the O1 Preview zero shot outperforms GPT-4o, GPT-4 Turbo, like all of the essentially non-reasoning models, even when leveraging those additional prompt engineering methods like ensembling and FewShot prompting. And so another kind of point be made there. And I think most interestingly, so they took O1 and they ran it through the Medprompt framework, and they kind of isolated each one of those prompt engineering methods that were added on. And what they found was that FewShot prompting, whether random or KNN, resulted in much worse performance, as you can see from the charts here. And this aligns with something that OpenAI actually has listed in their documentation that says, limit the additional context in RAG. While FewShot technically is in RAG, it is. It's just not retrieving out to a database. Saying this can prevent the model from by overcomplicating its response. So this is something to keep an eye on. In this case, we were sending 5 examples. So if you want to try this, maybe 1 or 2, and if not, maybe none. And this was just the template used. And then next up, they tested a baseline prompt versus a tailored prompt. So tailored prompts can just be like more specific to the task, you think, rather than just like a very simple, straightforward zero-shot prompt. And minimal gains there. Ensembling had the best kind of bang for your buck. That's even pretty minimal, and it's also had to run the prompt 15 times. So, that's going to cost a lot of money. And then lastly, they did a study of the impact of their reasoning tokens. And so by increasing the number of reasoning tokens, they saw pretty consistently a rise in performance. Some of it pretty notable. And they tested this by doing a quick response template and then another template that extended that reasoning to basically just tell it to kind of think more and whatnot. And it did actually generate more reasoning tokens in that case. And so, you could say there's a correlation from more reasoning tokens to higher performance. So if latency isn't an issue and you want to kind of squeeze out better performance, that's something you can potentially reach to in the prompt. And then there's a heat map. This is also included in our blog post if you wanted to see how the different methods kind of interact and either result in positive or negative performance. And moving on now, we'll talk about kind of when to use reasoning versus non-reasoning. That first paper we covered put together a pretty good framework for this because I specifically tested for it. So it really comes down to the number of reasoning steps. So for tasks that have 5 or more reasoning steps, O1 Mini outperformed GPT-4o by 16%. It was on, again, this code either generation task, I believe it was. And then for when it was under 5 steps, O1 Mini, that kind of delta got much smaller, like 2.89%. And then for very simple tasks with less than 3 steps, O1 actually underperformed 4o in 24% of cases due to excessive reasoning. So basically, you want to be able to figure out how many steps there are and then make a decision based on either that kind of framework there. And you could do this in terms of figuring out how many steps there are by going over to ChatGPT, plugging in your prompt and seeing how many steps it generates in the in its kind of chain of thought, because that's the most insight we have into that right now. Another thing to note, in those code generation tasks, nearly 40% of the outputs didn't match the code segment structure, which required post-processing, while GPT-4o via structured outputs and was other types of things was able to just give better outputs that aligned with the structure. And then sometimes with O1, the reasoning can kind of leak out into the answer, which can be desired or not desired. So that's something to keep in mind as well. And then, of course, when making this decision, cost and latency is very use case specific. And as we saw in the first paper, like you can get GPT-4o to O1 level of performance. It takes some work, but there's give and takes in terms of cost and latency. We covered 2 more papers in our blog post below about text to SQL tasks and hallucinations in terms of the performance of the different reasoning and non-reasoning models as well, if you want to check those out. But coming to kind of some best practices as a wrap up, using minimal prompting, like you don't need to overcomplicate things for the O1 models. If you need to get better performance, you can try and encourage more reasoning. It will take more time, but you could test that out. Avoid few shot prompting, or if you're going to do it, only have like an example or 2. I would say don't really include chain of thought prompting to the O1 models. It's just simply not necessary since it's built in. If the reasoning is 5 or more steps, using an O1 model makes sense. There is some formatting, output consistency with structure and with O1 models, they're in reasoning models, to kind of keep in mind. You can try ensembling. It could be costly, but we did see that actually did increase performance, and then cost and latency as well. And so just under 10 minutes here. It was really fun digging into this. Let me know if you have any questions about the differences between using the 2 models, picking between the 2, or prompting with the 2. Thanks.